What's up everybody? In this video, we are going to review adding additional sensors to your motor driver distance detection. You may find that you need more than one sensor to help your robot detect danger. For this video, we will look at adding a second ultrasonic distance sensor. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our motor driver distance indicator sketch. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Motor Driver-Multiple Sensors. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Motor Driver-Multiple Sensors, and the description is a sketch where we will use multiple sensors for collision detection. Before moving forward, let's review what we previously built. Click Start Simulation and ensure the serial monitor is displayed. You will see our circuit start up and the LED will blink using our thinking pattern. If you click on the ultrasonic distance sensor, you will see a ball that we can click and move. When you do this, the distance will show up in our serial monitor. If we move the ball outside of the field of view, the serial monitor will show that it cannot properly detect a distance. Because of this, we want to add an additional sensor to improve our robot's ability to detect danger. Let's add a second ultrasonic sensor. Search the components using the keyword distance and select the ultrasonic distance sensor under Other Components. Connect the VCC pin to power on your breadboard using a red wire. Connect the GND pin to ground on your breadboard using a black wire. Connect the trigger pin to pin 2 on the Arduino and the echo pin to pin 1 on the Arduino. Since we know our code works for the first ultrasonic sensor, let's make use of that code to test our new sensor. In your variables declaration, change the trigger pin to 2 and the echo pin to 1. Click Start Simulation and ensure the serial monitor is open. Click the ultrasonic sensor and try moving the ball around. Check the values you are getting in the serial monitor. It's showing a 0. And the robot performs the avoid collision function. So why is this happening? If you look at pin 0 and 1 on the Arduino, you will notice an RX and TX. These pins are used to receive RX and transmit TX data using the serial port. In our setup function, when we write serial.begin, this uses the pins for serial transmission and enables us to debug our code. If we don't use the serial monitor, then we can use these pins. If you comment out the serial.begin function in our setup code and click Start Simulation, you will notice that our circuit works. We can select the ultrasonic distance sensor, and if we move the ball past the thresholds, we will see the correct operation. However, if you look at the serial monitor, nothing is displayed there. We still want to use the serial monitor, so let's explore if there's another option. Uncomment the serial.begin before moving forward. We are going to need all the pins connected to the motors and the other ultrasonic sensor. We could remove one of the pins from the RGB LED, but we made that cool thinking pattern, and it shows us what the robot sees. That's pretty useful. It looks like we don't have any pins on the Arduino to use. Or do we? We have our analog in pins. If you look at the Arduino documentation, while their main function is to read analog sensors, they have the same functionality as digital pins 0 to 13. Let's test this out. Click the trigger pin wire and move it to A0, and click the echo pin wire and move it to A1. In your variable declaration, change the trigger pin to A0 and the echo pin to A1. Click Start Simulation and ensure the serial monitor is open. Click the ultrasonic sensor and try moving the ball around. Check the values that you're getting in the serial monitor. Cool! It's working and we didn't have to remove any of our sensors. Now, we need to add code so we can read both sensors. Update our variables. Since we have two distance sensors, we will need to declare variables for both. I'm going to refer to them as my left and right sensor, since that is what I have done with my motors. You can use whatever terminology you want, just ensure you have each sensor defined. Update trigger pin to trigger pin left, and update echo pin to echo pin left. Change the distance to distance left. We are going to do this because we want to measure two distances, one for each distance sensor. Let's update our variables in our main loop. Change distance to distance left, trigger pin to trigger pin left, and echo pin to echo pin left. In the remaining lines of the main loop, change distance to distance left. Let's add variables for our right sensor. In our variables declaration, copy and paste the declarations for the left sensor. Change the word left to right and update the trigger pin right to 12 and echo pin right to 13. Next, in our main loop function, let's update the distance right variable. After we update the distance left variable, type distance right equals get distance, open bracket, trigger pin right, comma, echo pin right, close bracket, semicolon, and add serial.print, open bracket, quotation mark, space, quotation mark, close bracket, semicolon, and serial.println, open bracket, distance right, close bracket, semicolon. Change the serial.println, open bracket, distance left, close bracket, semicolon, to serial.print, open bracket, distance left, close bracket, semicolon. Click Start Simulation. Click on either of the ultrasonic sensors and move the ball. You will see that our circuit is reading the distance for both the left and right sensors. This should also illustrate how useful a function can be. With our getDistance function, we pass the trigger and echo pin for whichever distance sensor we want. The last thing we need to do is update our case statements. In our first if statement, add vertical bar, distance right is less than or equal to 10, and add vertical bar, distance right is less than or equal to 20 in the else if. So what does this mean? We can add something known as a logical OR inside our if statement. What this means is if either of these statements is true, it will execute the code. So if either one of my distance sensors detects a change, it will respond accordingly. Click Start Simulation and test it out. You will see that when you test each of the ultrasonic sensors, it will trigger the robot to change its behavior. You now have two ultrasonic sensors that increase your robot's field of vision. At the end of this video, you should have a better understanding of how to connect two ultrasonic sensors to an Arduino and use a logical OR within a conditional statement.